Hi everyone, I am Mrs. P. Indumati, Assistant Professor, Department of Pharmaceutical Chemistry and Analysis, School of Pharmaceutical Science, VISTAS. Today, I am going to present an important topic from Pharmaceutical Inorganic Chemistry, namely limit test. In this presentation, we are going to understand the concepts of limit test and then discuss three commonly performed pharmacopoeial limit tests, that are limit test for chloride, limit test for sulfate, and limit test for iron. These tests are very important in pharmaceutical quality control laboratories because they help us ensure that medicines are free from harmful inorganic impurities and are safe for the patients. So, let us begin with the basic concept. Before learning individual tests, we must first understand that what a limit test actually means. A limit test is an official pharmacopoeial test which is used to detect and control small amounts of impurities present in a pharmaceutical substance. The important point is that it is not an exact quantitative analysis. It only tells us whether the impurity is within the prescribed limit or exceeds the limit. In every limit test, we prepare two solutions: a test solution from the sample under the examination and a standard solution containing a known amount of impurity. Both are treated with the same reagents under identical conditions, and then we compare them visually. Think of it as comparing two glasses. If the sample looks less cloudy or less colored than the standard glass, the sample is considered acceptable. So these tests are popular because they are simple, quick, economical, and suitable for routine laboratory work. Moving on to the next slide, we are going to see why we have to perform the limit test. What's the reason for performing the limit test? So there are four major objectives are there. First one is to ensure the compliance with the pharmacopoeial standards such as IP, BP, and USP. And the second one is to protect the patient safety by preventing toxic inorganic contaminants from reaching the patients. Third one is limit tests that are very simple and rapid. They do not require high expensive instruments such as HPLC or spectrophotometers. And finally, they are generally used, routinely used in quality control laboratories during raw material testing and batch releases also. So, limit tests are practical tools for maintaining pharmaceutical quality. Moving on to the next slide, all the limit tests follow the same basic principle. We prepare the test and standard solutions under identical conditions. The same reagent is added to both the solutions. The reagent produces either turbidity, opalescence, or color. The intensity produced in the test solution is then compared with that of the standard solution. These tests are usually carried out in a nestless cylinder against a dark or white background. The simple rule to remember is the test should not be more intense than the standard solution. So this single statement applies to almost all the pharmacopoeial limits. So different impurity require different reagents. Like chlorine reacts with the silver nitrate and it produces the turbidity. And sulfate reacts with the barium chloride and it produces turbidity. Iron reacts with thioglycolic acid and it produces the purple color. Arsenic is tested by the Goodsite method, and heavy metals reacts with the sodium sulfide or thioacetamide also. Lead is tested using diethazone. In today's presentation, we will focus mainly on chloride, sulfate, and iron because these are frequently asked in examinations and also commonly performed in laboratories. Let us now begin with the limit test for chloride. Chlorides are commonly present because many pharmaceutical substances are prepared using hydrochloric acid or chloride salts during the manufacturing process. The principle is very simple. Chloride ion react with the silver nitrate in the presence of dilute nitric acid to form silver chloride, which appears as a white opalescence. You can see the reaction here. NaCl, when reacts with the silver nitrate, it leads to the formation of silver chloride and sodium nitrate. This silver chloride is responsible for the formation of turbidity or opalescence in the Nessler cylinder. The amount now let us understand the procedure step by step. First, dissolve the sample in water and transfer it into a Nessler cylinder. Second step is add dilute nitric acid to both the Nessler cylinder, that is test as well as standard solution. Third one is make both the solution up to the same volume, that is usually 50 ml mark, which is mentioned in the Nessler cylinder. And fourth one is add silver nitrate solution to both the cylinders. And fifth step is mix well and allow the solution to stand for about 5 minutes. And finally, observe the opalescence against the dark background. I usually ask the students to remember the sequence as follows. First one is dissolve, and second step is acidify the solution with nitric acid, and third one is equalize the volume, and final one is add silver nitrate and compare. So this sequence helps the students to prepare for the viva examinations also. And we have to know what is the reason for the addition of silver chloride, as well as what's the reason for the addition of dilute nitric acid. And so why we are adding nitric acid is in order to make the solution acidic, and then the silver nitrate, when reacts with the sodium chloride, it leads to the formation of silver chloride. So this silver chloride is responsible for the formation of opalescence. That students has to remember that one. Moving on to the next slide, the interpretation is straightforward. If the opalescence in the test solution is less than or equal to the standard solution, the sample passes the test. If the solution is more opalescent than the standard, the sample fails the test. Here, the key viva statement is the test solution should not show the greater opalescence than the standard solution. If it shows, the given sample fails the test. Next limit test is a limit test for sulfate. We are going to see a brief introduction for the limit test for sulfate in the upcoming slides. Let us discuss a limit test for sulfate. Sulfate impurities may originate from sulfuric acid or sulfate salt or during the manufacturing process also. The sulfate ion generally react with the barium chloride to form insoluble barium sulfate, and it leads to producing the turbidity. As we can see the reaction here, a sulfate when react with the barium chloride, it leads to the formation of barium sulfate. So this barium sulfate is responsible for the formation of turbidity. Here we will add hydrochloric acid. The hydrochloric acid is added to prevent other acid radicals from precipitating, and alcohol is added. Why we are adding alcohol is to increase the sensitivity of the test. Again, here also the same condition, the greater turbidity indicates the greater sulfate content. The procedure is as follows. We are going to take 1 ml of barium chloride solution in both the Nestle cylinders, test as well as standard solution. We are going to add sulfate, ethanolic sulfate standard solution to both the Nestle cylinders. Add a test sample solution to the cylinder and standard sulfate solution to the standard cylinder. To the both the cylinders, Nestle cylinders, we are going to add acetic acid and make up the volume with sulfate free water and compare the turbidity against the black background. The black background makes the turbidity easier to observe. For that reason only, we are observing under the black background. So interpretation is similar to chloride test only. The test turbidity should be less than or equal to the standard solution. If it is less or equal, the sample passes the test. The test turbidity is greater than the standard means it leads to fails the test. So remember, test should not be more turbid than the standard solution. So next slide is limit test for iron. Now let us move to the limit test for iron. Iron contamination is important because iron can catalyze oxidation reaction and affect the stability, color, and shelf life of the pharmaceutical product. In this test, iron reacts with the thioglycolic acid in an alkaline medium to form a purple colored ferrous thioglycolate complex. The first thioglycolic acid, what it does means it reduces the ferric ions to the ferrous ion, and ammonium citrate keeps iron dissolved and prevent the precipitation process. Even a trace of iron can produce the purple color. So let us see the procedure. Dissolve the sample in water and iron-free acetic acid solution. So iron-free citric acid solution. To the solution, to this Nestle cylinder, add thioglycolic acid and make the alkaline solution alkaline using the ammonia. So dilute the volume and compare the purple color with the standard solution. An important point is that purple color develops only in an alkaline medium, so the ammonia step is essential one. So interpretation is again based on the comparison process only. Test color less than should be less than or equal to the standard solution. Then it indicates the solution passes. And then test color should be greater than the standard solution, means it indicates the solution is fails. For viva examination, student has to remember the solution should not show greater purple color intensity than the standard solution. Let us summarize all the three tests. In limit test for chloride, silver nitrate reacts with the chloride. It leads to the formation of a silver chloride. This silver chloride is responsible for the formation of opalescence. In the limit test for sulfate, barium chloride reacts with the sulfate to form barium sulfate. This barium sulfate is responsible for the formation of turbidity. In the limit test for iron, iron reacts with the thioglycolic acid. It leads to the formation of purple color. So the color intensity is compared with the standard solution. The common feature in all the three tests is that the test and standard are prepared identically and compared visually. This comparison principle is the heart of the limit test. To conclude, the limit tests are simple, official, comparative methods used to control inorganic impurities in pharmaceutical substance. We studied the principles, reagents, procedure, and interpretation of the limit test for chloride, for sulfate, and iron. The most important rule is a sample passes only when the appearance of the test solution is not more intense than the standard solution. These tests play a crucial role in pharmaceutical quality control and ultimately help ensure the safety and quality of medicines supplied to the patients. So, with this short lesson, I would like to thank you for your attention. I hope this presentation has given you a clear understanding of the limit test in pharmaceutical inorganic chemistry. Thank you. Thank you once again.